So Ryan Wynn says, I uploaded a picture of the problem I needed help with. I'm not sure how to solve it. This one says, simplify the following trigonometric expression by following the indicated direction. So it says multiply cosine of theta divided by sine of theta minus 1 by a sine of theta plus 1 divided by sine of theta plus 1. All right, so let's get into it, Ryan. So if I multiply this, cosine of theta divided by sine of theta minus 1, and we're going to multiply that by a sine of theta plus 1 divided by a sine of theta plus 1. Okay, now the cool thing when you're multiplying fraction, numerator times numerator, denominator times denominator, right? Now these are binomials, so I'm going to, or they have, not really binomials, but they have two terms in here, so I'm going to put parentheses around them. Now, what I recognize here is I have an expanded form of the difference of two squares, right? Because if you remember, if I have a minus b times a plus b, when you multiply that out, when you use FOIL or distributive property, you're going to get an a squared minus a b squared. Okay. So immediately over here, I say, hey, I can rewrite my denominator as a sine squared minus 1, because that's what I have here. Now, up top on this numerator, I'm not going to do that yet. You could distribute the cosine to both of those terms, but a little tip that you kind of learn when working with identities is not always do you always want to expand things. A lot of times we want things to divide out, right? So if I want things to divide out, I'm going to kind of wait till the last moment I have to simplify it before I just distribute, right? And it's more work, but there's nothing mathematically wrong with multiplying this out. I just know through experience, I want to look for the sine of theta plus 1 to be in the denominator so I can divide out, or cosine to be in the numerator denominator. That's what I want to look out for. So I don't want to multiply it out yet, because then I'll have to like factor it out, and that's kind of annoying. So I'm going to leave it in a factored form. So cosine of theta times sine of theta plus 1. And then my denominator here is going to be a sine squared of theta minus 1. Now, one thing I always tell my students is whenever we see sine squared, cosine squared, or tangent squared, or any trigonometric function squared, I like just think of like a little bell, like ding, 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 like think of your Pythagorean identities. It's not always the case, but more often than not, it is the case that there is going to be, you're going to want to use a Pythagorean identity. So what is the most famous Pythagorean identity of all? Well, that's going to be sine squared plus cosine squared equals 1. If you don't have that memorized, then please just go in and memorize it. I'm not a big proponent of memorizing a lot of stuff in math, but I really think this is one that you just need to know. Are you going to use it in real life? No. Are you going to use it when you go to the grocery store? No. But it's used so often in upper level and mathematics when we're doing trig. It's just, you need to know it. Okay. Now, this is our Pythagorean identity. This is not the same as that. But what if I go ahead and subtract a 1 on both sides and subtract a cosine squared of theta on both sides? Come on. Oh, no, I ran out of room. I know it's going to do that. So if I subtract, let's move this over. So if I subtract this minus a cosine squared of theta, so then I'll have here is a sine squared of theta minus 1 equals a negative cosine squared of theta. So what that means is sine squared of theta minus 1 is equal to negative cosine squared of theta. Now, why would I want to swap that out? Because again, remember what I mentioned at the beginning? I want the same thing in the numerator and the denominator so I can simplify it, right? If I have 4 over 2, is that simplified? No, right? What we want to do is you could break up 4 into 2 times 2 divided by 2. 2's divide out. That simplifies to 2, right? We want to find things in the numerator and denominator that divide in or divide to 1. That's going to simplify our expression. So I want a cosine in the denominator. That's good, right? These are not the same. This is sine squared. That's a regular sine. You can't divide those out. So I'm going to replace my sine squared of theta minus 1 with a cosine of squared. So let's see what that's going to look like. So if I have a cosine of theta times a sine of theta plus 1. Now, one thing you can do, remember cosine squared is the same as cosine times cosine, right? So I'm just going to rewrite this as a negative cosine of theta times a cosine of theta. You don't have to do this, but this is just for our counting purposes. So you guys can see that these cosines divide out. And now I have a negative in the denominator, but again, you can have a negative denominator or you can have a negative numerator, or you can just write the negative in front. It doesn't really matter. Just make sure you only put it in one or the other. So then I'm going to have a final answer of sine of theta plus 1 divided by a cosine of theta. So that's a negative. It just looks weird. I'll do it with the blue. But yeah, it's important when like on like a test, like the SAT, ACT, or an exam, like if you have any multiple choice answers, they might have a negative with the negative in the numerator, or they might put the negative in the denominator, or they might have the negative in front. So you need to feel comfortable being able to put that negative in different directions.